All right, this is Module 3 Review, Part 2. Okay, this is Chester's babysitting service. Chester charges $6 an hour to babysit. Complete the table above. Well, if it's $6 every hour, then for 2 hours it's 12. 4 times 6 is 24. 10 times 6 is 60. If he babysits 12 hours, $72. 14 hours, 84. Write an equation that shows the relationship in the table. Well, let's look at the relationship in the table. Let's look for a constant of proportionality. So we're going to look at not the changes, but just the ratio of y to x. Now remember, y is dependent upon x. The number of money you make is dependent upon the number of hours that you work. So these are the y's. So we have 12 over 2, 24 over 4, 60 over 10, 72 over 12, and 84 over 14. And if you will notice, every single one of these ratios simplifies to 6. So that means that it has a constant of proportionality of 6. So my equation would be y equals 6 times every x value. All right. Oh, there was a hint. You have to figure out which variable is x and which variable is y before writing the equation. Good point. Which one's dependent and which one is independent. On the graph below, draw a line that intersects the y-axis at 0, -3. Okay, here's the point where x is 0 and y is -1, 2, 3. So our graph is going to intersect the y-axis at that point, and it has a slope of 4 over 1. Hint, it won't go through the point of origin since it already touches the y-axis at -3. Start at that point. So we're going to start at -3 and we're going to rise 4 and run 1. Start at -3 because we know that point's on the graph. We're going to rise 4, run 1. Rise 4, run 1. Can't rise anymore because my graph's not big enough. But as you can see, this is going to be a straight line if we connect those points. And it does not go through the point of origin, so this is not proportional. It's linear, it has a constant rate of change, but it's not proportional. It doesn't go through the point of origin. What is a unit rate? Simply said, unit rate means per 1. If I go 120 miles in 3 hours, then my question is, how many miles can I go in 1 hour? Because per 1 hour is my unit rate. Now you can cross multiply, this is a proportion, and you can solve it, or if you want, you can just do 120 divided by 3 is 40. You go 40 miles in 1 hour. Per 1 unit is a unit rate, So if my ice maker freezes 70 pounds of ice every 3.5 hours, what is the amount of ice it makes per hour? So if I make 70 pounds of ice per 3.5 hours, how much ice would I make per 1 hour? What's my unit rate per 1 hour? There's my proportion. I can cross multiply and isolate the variable, or in this case I can just divide 70 by 3.5, and when we're dividing, our divisor, this guy out here, has to be a whole number. So I'm going to multiply this guy by 10 so that 35 is my whole number, but since I multiplied this by 10, I have to divide my dividend also by, multiply my dividend by 10. So 3.5 becomes 35 and 70 becomes 700. How many 35s are in 7? None. How many 35s are in 70? 2. 2 times 35 is 70. I'm not done because my decimal is clear over here. So I have to bring down one more 0. How many 35s are in 0? 0. 0, subtract. So I'm left with 20 pounds of ice per 1 hour. So my 20 would go right there. This is a unit rate, 1 hour. So then I could figure out, well, how much ice would it make in 4 hours? I would just multiply this times 4. 10 hours, multiply this by 10. Unit rates are really convenient. Use the graph below to find the unit rates of graph X and the unit rate of graph Y. Okay, unit rate means per 1, doesn't it? So 3 over 1, I get 3, let's just pretend like this is hot dogs, just for fun, and let's pretend like this is per hour. So this would be, in 1 hour, it would be 3 hot dogs, so it would be 3 hot dogs per 1 hour. That's my unit rate for this graph right here, which is Y. So Y is 3 per 1. And let's look at this one. If I have 1 hour on this graph, I'm going to eat 4 hot dogs. So that would be 4 per 1, or 4 per 1. It's actually the rise and the run. Okay. You know what? That's wrong. Because these aren't proportional. I need to take 2 points and find the rate of change, don't I? That was silly. So if I take 2 points, I'm going to go up 2 and over 1. Up 2 and over 1. So my unit rate is 2 per 1 hour. He already ate 4, and now he's going to eat 2 more every hour. 2 more every hour. This guy already ate, looks like 2.5. So let's pick 2 points that are right on corners, and he's going to eat 2 hot dogs in 1, 2, 3, 4 hours. 2 hot dogs in 4 hours, which simplifies to 1/2 hot dog every hour. So this one, X, is 1/2 per hour, and the other one is 2 per hour. Sorry about that, guys. So we had to do the rate of change by picking 2 points. If Norelli runs at a constant rate, she can run 6 miles in 48 minutes. 6 miles in 48 minutes. Predict how long it takes her to run 7 miles. If she can run 6 miles in 48 minutes, the question is, how long will it take her to run 7 miles? Let's make a proportion, and if I'm going to put 7 miles, it's going to go on top because my miles are on top over here. So my miles are on top and my minutes are on the bottom. So 6 miles in 48 minutes is equal to 7 miles in how many minutes? So we can cross multiply. 6x equals, and 7 times 48 is 280, and 56 is 336. And then if you divide both sides by 6, you get x equals 56, I believe. Yes. Now let's look at that one more way real quick. What if we had flipped this around and said 48 minutes and 6 miles. Could we have figured out how many minutes it took to run 1 mile? Absolutely, because if we simplify this, we would get 8 over 1. It would take 8 minutes to go 1 mile. So how long would it take to go 7 miles? Well, 8 times 7 would be 56, which is the same answer we got down here. She can go 56, or it takes her 56 minutes to run 8 miles, and that's equivalent to a unit rate of 8 minutes per 1 mile. Okay, that's it.